Welcome to the fourth lecture on Odisha SSB lecturer question solution. In our third lecture, we had completed up to the 15 number question, and in today's lecture, let's start from 16 number question. So the 16 number question was about the brachystogram problem. It has asked to find the path. We know that it follows any particle in brachystogram problem follows a cycloid path, and let's see what is the path, what is the nature of this path. The equation of this path, this type of cycloid path is y equal to a whole into theta minus sine theta. Okay, so if you see that this graph here, there are three equimassed particles or identical particles which are starting from this point, from a point. Okay, from this point they are starting from, all these three particles are starting from this a point, and they are going to meet at a b point, point b. Okay, here is the point b, and if you release three particles simultaneously, then you will see that, you will notice that this particle, okay, this particle will meet first at this point b. This means that particles always follow a path which needs less time. Okay, very less time, or you can say the least path, least time. So this path, the red color path, sorry, this path followed by this middle particle, this path is known as cycloid path. Okay, and the solution and the equation of this path is this. Okay, now coming to the 17 number question. The question was about the Fermat principle in geometrical optics. It's very simple. We know that Fermat principle is related to the principle of a least action. Okay, now coming to the 18 number question. The 18 number question about the generating function related to identity. Okay, if you see the solution, this f is should be q, small qj and capital pj, and this f is the second generating function, because second generating function is a function of a small q and a capital P. This is the second generating function. Okay, now if you find small pk, then you have to differentiate this f2 function with respect to q, small q, and if you differentiate, and you will find that small pk is equal to capital Pk. And likewise, if you differentiate f f2 second generating function with respect to capital Pk, then you will find small qk is equal to capital Qk. So as we are getting, as in this transformation we are getting the old coordinate or old canonical coordinates are equal with the new canonical coordinate. Like you see here, this pk, this is a small pk, this is a old coordinate, it is equal to the new coordinate capital Pk, and here also this small qk, this is an old coordinate, it's equal to, it is also equal to the new coordinate capital Qk. So this type of transformation is known as identity transformation, and this is followed only when this generating function should be f2, and f2 is a function of qj and capital P, sorry, capital small q and capital P. Okay, so now coming to the 19 number question, it is asked to find the transformation, and this is a canonical transformation, and we have to find at what value of alpha and beta this transformation is a canonical transformation. That means qp, Poisson bracket of qp should be 1. So how can we find? You have to use that Poisson bracket. This is the Poisson bracket, it should be 1. Okay, this should be 1, and it's a more hectic process, just calculation, and it's a lengthy process, so you have to do like this. It's better to remember, okay? Because in such type of exam like SSB, it will provide you only 2 hours, okay? So within that 2 hour uh, you have to achieve more and more question, okay? So it's better to remember this. If you do this type of question at any point of time, then you should remember it, so that it will be easy when you do this type of exam. So after calculation you will get alpha and beta should be half and half, okay? So now coming to the last question, that is 20 number question. It is asked to find the Poisson bracket of two constant of motion. Achha, okay. The Poisson bracket of two constant of motion should be a constant of motion even if the constants are constants have explicitly time dependent. This is the correct. Such type of question has already been asked in get. If you do if you solve the get questions, then you eventually find this question, okay? It has been asked already, okay? So these are the solutions, and this is the 17 number questions solution. Fermat principle. The least action means where action is integration a to b, okay? And L dt, L is the Lagrangian. For least action, this action should be means del s should be uh, del of integration L dt. That means del integration of a del L dt should be 1, because for least action that means this action should be 0, okay?